All right, let's get right into it. Today, we're going to be digging deep, and I mean that literally. We're talking about the groundwork of every single structure around us. Foundations. They're kind of the hidden heroes, the critical part that makes sure our homes, our offices, and even massive bridges stand tall and, more importantly, stay put. So let me start by asking you a question. When you look up at a giant skyscraper, just this incredible feat of engineering, what do you think is the single most important part? Is it the steel frame, maybe the super fast elevators, or, that shiny glass all over the outside?
Well, you've probably guessed it by now. The answer is the part you can't even see. It's the foundation. It's the thing that connects that massive, massive structure to the earth itself, managing these incredible forces and keeping it all stable. And today, well, we're going to bring it out into the light.
Okay, so here's our game plan for this explainer. First, we'll talk about what a foundation actually does. Then we'll get into the big difference between shallow and deep types. After that, we'll take a tour of each, and finally, we'll look at what happens when things go wrong. Let's get you ready for any exam on this stuff. So first things first, what even is a foundation? Put simply, it's the part of a building that's in direct contact with the ground. Its main job, its whole purpose, is to safely take all the loads from the building, that's the weight of the materials, the people inside, even the force of the wind, and transfer them into the earth. But, a foundation's job is way more complex than it sounds. It doesn't just dump the load into the ground. It has to spread it out to reduce the pressure, make sure it's distributed nice and evenly, and create a perfectly level base to build on. On top of that, it provides stability against sideways forces like wind or earthquakes. It's a real multitasker down there. Now, we get to the first big decision an engineer has to make. See, not all ground is created equal, so foundations are split into two main categories: shallow and deep. And this choice, right at the beginning, it sets the stage for the entire project. And the crucial difference really boils down to a super simple ratio: depth versus width. If the foundation's depth is less than its width, and the soil near the surface is strong enough, you're looking at a shallow foundation. But if you have to go way down to find strong soil, the depth is going to be greater than the width. And that's when you need a deep foundation. It's as simple as that. All right, let's start our tour with the most common shallow foundations. These are the absolute workhorses you'll find under most of our houses and smaller commercial buildings. We're going to take a look at how each one works. So first up, we've got spread footings. These are the simplest and by far the most common type. The best way to think of them is like the feet on your body, right? They take the concentrated load from a single column or a wall, and they just spread it out over a wider patch of soil. That reduces the pressure to a level the ground can actually handle.
And as you can see, spread footings come in a few different flavors. For a single column, you might just use a simple square pad. Or you could use a stepped or a sloped design to be a little more efficient with your concrete. And for a long, continuous wall, you use what's called a strip footing that just runs along the whole length, just like you see in the diagrams at the bottom.
Okay, but what if your columns are too close together for their own separate footings? Or what if one is right up against the property line so you can't put a footing right in the middle of it? Well, that's where you need a cleverer solution, like a combined footing or a strop footing.
The difference between them is pretty straightforward. A combined footing, on the left, is just one single slab that supports two or more columns. A strap footing, on the right, is a bit different. It uses a really stiff beam to connect two separate footings, which helps to share the load between them. Okay, now I want you to take that idea of a combined footing and just scale it up. Like way, way up. That's a mat, or as it's sometimes called, a raft foundation. It's basically one giant footing that covers the entire footprint of the building. The whole structure literally floats on top of this concrete raft. Now, definitely pay attention to this slide if you're prepping for an exam. A mat foundation is your go-to solution when the soil is pretty weak or the building's loads are just incredibly heavy. It's also fantastic for preventing something called differential settlement, and that's a big problem where one part of the building sinks more than another. Okay, so now let's go deeper. What happens when that strong, stable soil you need is 50, maybe 100, or even 200 feet down? You can't just dig a giant hole. You have to send the foundation down to meet it. So welcome to the world of deep foundations. The most common type of deep foundation is the pile foundation. These are basically long, skinny columns that are either hammered or drilled into the ground, and they work in one of two ways. They either rest on a solid layer of rock deep down, that's called end-bearing, or they use the friction of the soil all along their sides to hold them up, and we call that skin friction. This diagram here shows it perfectly. Take a look at A, the end-bearing pile. It acts just like a simple post resting on hard ground. Now look at B, the friction pile. That one's being held up by the soil gripping its sides. And, of course, you can have a combination of both, which gives you the best of both worlds.
Next up, we have pier foundations. The easiest way to think of a pier is like a very, very large diameter pile. But instead of being driven into the ground, a hole is dug out first and then filled with concrete. You use these to support extremely heavy, concentrated loads.
And there are a few ways to build these piers. You can use simple masonry, like bricks or stone, or you can use a more modern method called a drilled caisson, which is often shaped like a bell at the bottom to spread the load out even better. Another way is to just pour concrete inside a permanent steel shell.
And finally, for the truly massive projects, especially ones in or near water like bridges and wharves, we have well foundations. They're also known as caissons. These things are huge, hollow structures that are sunk down through the soil and water until they hit a solid layer to rest on.
And here's a look inside one. The real key feature is that cutting edge right at the bottom. Workers dig out material from inside the well, and the structure's own incredible weight forces it to sink down, cutting through the soil until it finally reaches its target depth. Pretty cool, right?
So we've seen all the different types, but I gotta tell you, getting the choice right is absolutely critical. Because when the groundwork is wrong, the problems are serious and they are always, always expensive to fix.
These are the main culprits behind foundation failure. The most common one by far is unequal settlement. That's where one part of the building sinks more than another, which causes cracks and huge structural stress. And this can be triggered by all sorts of things, from patchy soil conditions to changes in groundwater or even nearby construction.
So there you have it. We've toured the entire world of foundations, from simple, shallow slabs to these massive, deep caissons. But all of this raises a huge question, right? How do engineers actually choose the right one? How do they know what the ground is like hundreds of feet down? Well, that all comes down to soil exploration, which is a deep dive all on its own, and maybe a story for another explainer. Thanks for joining me.